This is 4-2, classifying triangles. Let's take a look at the warm-up. We need to classify each angle. Pause the video so that you can check your answers when you are ready to see them. Example 1 is right angle, 2 acute angle, 3 obtuse angle. Example 4, we add up all the sides to equal the perimeter, which is 47. 47 units, I should say. So I combined like terms and I ended up with 6x plus 17 equals 47. I solved for x and I got x equals 5. So to find the length of each side, I would plug that 5 in. 2 times 5 is 10 plus 6 is 16. 5 plus 3 is 8, and 3 times 5 is 15 plus 8 is 23 units. So all of these would be units. And the last one, sorry, it's not a warm-up, but a triangle is a polygon with 3 sides. Okay, so triangles can be classified in 2 ways. We can use angle measures, or we can classify them by their sides. So one of the ways we could classify triangles is by angle measures. And when we use angle measures, there's 4 options. We have an acute triangle, which contains 3 acute angles. We have an equiangular triangle with 3 congruent acute angles. We have a right triangle that contains 1 right angle, and we have an obtuse triangle that contains 1 obtuse angle. The only one I think you guys haven't seen before is maybe equiangular. We're used to equilateral, but that has to do with the side lengths. Equiangular is the same thing. It has equal angles. Equiangular. Okay, example 1 says to classify each triangle by its angle measure. So the hardest part of this is going to be to really see which triangle they're talking about. So I'm going to highlight it. This one says triangle BDC. Triangle BDC is only this blue part. So it does not include this little bit on the end. Just the blue for triangle BDC. I want you to notice that BDC does not contain that 90-degree angle that's down here, because that's in both of those angles. But it does have this 100-degree angle, which makes it an obtuse triangle. Now we're looking at triangle ABD. Triangle ABD is this little triangle right here. If one of those angles is 20 and the other is 80, I know that there's 180 degrees in a triangle, and we've used 20 and 80 so far, so we've used 100 degrees so far, which leaves this other angle is 80 degrees. So all of them are less than 90 degrees, which makes this an acute triangle. Let's look at example C, triangle EHG. EHG is going to be this whole triangle. So we have a 30-degree angle, we have this 60-degree angle, and then we have this large angle. We've used 30 and 60 so far. We've used 90 of 180 degrees, so that leaves us with 90, and that's what this right angle is referring to. This triangle EHG is a right triangle because of that right angle. Okay, triangle EFH. For triangle EFH, we have used, let's see, we've got this one's 30. This one's 30, so we've used 60 of 180 degrees. We subtract that and we get 120, so this is 120 degrees. We also know that since this was a linear pair, if that one's 60, then this one must be 120, because those add up to 180. But this makes this an obtuse triangle because of that one angle that's larger than 90 degrees. And the last one, triangle FHG. FHG is right here. We have a couple ways of knowing this angle measurement. We've used 120 so far of 180, and so that leaves us with 60 degrees. The other thing is this whole piece was a right triangle, so that was 90, and we've used 30 of that, and so there's 60 left. So you kind of have to use what you know about triangles already. We know that they add up to 180 degrees. We know complementary angles add up to 90. We know supplementary angles add up to 180. And we know that linear pair adds up to 180. Those are some helpful things that I used throughout these problems. So what did we decide? If they're all 60, this is an equiangular triangle. That was all based on just angles. To classify triangles by side length, we have 3 options. So for side length, we have 3 options. Equilateral, which is all 3 sides are congruent. Isosceles, which is at least 2 congruent sides. Because of that wording at least, an equilateral triangle is also an isosceles triangle. And a scalene triangle has no congruent sides. So let's look at triangle EHF, which is this triangle right here. We have 2 congruent sides marked by these tick marks. And so if at least 2 sides are congruent, this is going to be an isosceles triangle. Triangle EHG. EHG is this large triangle. We have this length, which is 14, 11, and 12. So all 3 are different, so that's a scalene triangle. Triangle ABC. Triangle ABC. Okay, these 2 sides are congruent, which means that this side length is also 15. And my third side is 15, and so this makes it an equilateral triangle. They were all equilateral. All 3 sides were congruent. Triangle ABD. ABD. We've got this combines to 20, 15, and 18. So all 3 are different, so that's a scalene triangle. Now that we can classify triangles, we can use that information to help us solve for x. So here we have an isosceles triangle, which means that I know that these 2 sides are equal to each other. I don't really know anything about that third side yet, so I'm not going to do anything with it. Now, side lengths do not add to 180. That's the biggest mistake that people make. Sides don't add to 180 degrees. That's only angle measures. So for sides, we have to know that something is congruent to each other. So since I know that these 2 sides are congruent to each other, JK and KL, I can set those equal to each other. Subtract 2x from both sides, and I would be adding 10.7 to both sides. I'm just going to do it all at once to save time. So I get 2x equals, let's see, 16, 17. And x equals 8.5. Okay, and then I can plug that back in to now be able to find each side length. And when I plug in x, we should get 23.3 for JK and KL, and JL equals 44.5 units. For example B, again, we only know that 2 things are congruent. We've got this piece congruent to this piece. So we'll set this up as an equation. Let's solve this equation. We end up with negative 3x equals negative 4.5. Divide both sides by negative 3, and we get x equals positive 1.5. And then we can plug that 1.5 into each to find each side length. When I plugged in x, I got 7.3 units for JL, and then JK and LK are the congruent segments for each 4.7 units. Example C, find the side lengths of the equilateral triangle. Well, just because they're all equal to each other doesn't mean that I need to use all of them at one time. So if it's equilateral, I have this, but I'm just going to set 2 of them equal to each other. So I'm just going to pick these 2. I picked a random 2. 3y minus 4 equals 2y plus 3. And I'm going to be solving for y. I got y equals 7. And when I plug 7 in, I get 3 times 7 is 21, minus 4 is 17 units. And I can do this for each one, but they're all going to come out the same. So 35 minus 8, 17 units. And 14 plus 3, 17 units. A manufacturer produces musical triangles by bending pieces of steel into the shapes of an equilateral triangle. The triangles are available in side lengths of 4 inches, 7 inches, and 10 inches. how many 4-inch, so the only thing we're worried about now are the 4-inch. How many 4-inch triangles can the manufacturer produce for a 100-inch long piece of steel? So if we have a 4-inch by 4-inch by 4-inch triangle, that's a perimeter of 12 inches. And if we have a 100-inch long piece of steel, we could take 100 and divide that by 12. That would give us 8 1/3 or 8.3 repeating triangles, but we can't make a third of a triangle. So the real answer to this would be 8 4-inch triangles.